Hi guys, it's Mrs. Valletta. I thought I'd make a quick movie and show you how to do the energy problems. Probably these are straightforward enough that you're not having any problems, but just wanted to give you a couple of pointers. So remember that kinetic energy is the energy of motion, and this is the formula for it. Occasionally you're going to have to rearrange the formula, so I thought we would do that together, like in the first one where we're figuring out how fast the ball is going. So we're trying to rearrange for velocity. All right, so I'm gonna underline V to remind us that we're rearranging velocity. And the first thing I'm gonna do is I'm gonna multiply both sides by 2, because if I do, then I'm gonna get rid of the 1/2, which is a constant. Okay, so we'll do this. And remember, we're trying to get velocity by itself, so I'll multiply this side by 2 and that side by 2. This cancels. The next thing I'm going to do is divide by the mass, because we don't want mass of the object on this side of the equation. That cancels. And now I get V squared is equal to 2 times the kinetic energy divided by the mass of the object. If I square root velocity squared, I'll get velocity, so I can square root the whole other side. And that's the formula that I can use to find the velocity of an object if we know it's kinetic energy. And I'm going to write velocity final simply to remind you that a lot of times we're talking about the transfer of energy or transformation, excuse me, from potential energy to kinetic energy. And so normally we're looking for the velocity final. I gave you the answers in a lot of these problems so that you can check your answers and make sure that you're doing it right. Remember, if you want to put this into scientific notation, here's our decimal. You have to move it until you have only one integer to the left of the decimal. And because this is a number larger than 1, you're going to get a positive exponent, not a negative exponent. All right, so those are my 2 advices here. Remember, this is the formula up here for potential energy. Little g is the acceleration due to gravity. Okay, and that's 9.8 meters per second squared. All right, last thing to remind you is down here talking about power. And when we're talking about power, we're talking about the rate that energy is used or dissipated. And that would be work divided by time or any other energy determination that we have. Here we've got an arrow that's fired by an archer. We got a force and a distance, so we can figure out how much work was done. And once we know how much work was done, we can just divide it by the time that he took to do the work. Okay, and then this is a pretty classic problem when we're talking about a ball at the top of the hill. It has potential energy at the top and no kinetic energy. As it rolls down the hill and gets to the bottom, all of the potential energy is transformed to kinetic energy. And so these two will be equal. But when we get here, it'll have both potential energy and kinetic energy. It'll still be moving, but it'll have this much potential energy, okay? And so you're just trying to find how much kinetic energy it has at the top of the second hill. Now, mechanical energy is conserved. So at any given time, the mechanical energy of the system is equal to the potential energy plus the kinetic energy. At the top of this hill, there is no kinetic energy. K is equal to 0 at the top. All right, so all the mechanical energy is potential energy here. At the bottom, there's no potential energy, and so all of the kinetic energy is the mechanical energy, and here we have a combination of the two. And so I give you a hint, figure out how much potential energy was transferred to kinetic energy. I'm not going to post answer sets because I've given you the answers, and you can use it to help troubleshoot whatever you're doing. Don't forget, all the formulas are at the top, and please email me or come to office hours if you have any questions. Thanks, and I hope you're doing well.